This video will show you how to create our first foldable, the real numbers. You will need a full sheet of orange paper and one each of the purple, the blue, the yellow, the pink, and the green. Take your orange paper and you're going to fold it in half, hamburger style, and place it on your desk so that it opens up. On the front cover, please write the words Real Numbers. Okay, once that is done, go ahead and open it. And the real numbers are any numbers that you can think of. This is our largest number set. Go ahead and write that on the inside of the front cover. And the next piece is the hot pink square. Okay, go ahead and glue that down on the right. You can see where mine is glued down. And the real number system is broken into two number sets. The first one is irrational numbers, and these numbers go on and on forever. And they don't repeat. They have to do both. They cannot be made into a fraction, and these are ugly decimals. So pi is our rock star. He is irrational. The square root of 2. If you take your calculator and type in the square root of 2, you're going to hit Control and x squared. See the square root above it? Type in your 2 and hit Enter. Okay, you'll notice that this looks like it stops, but your calculator has actually rounded it so that it doesn't just keep going forever and fill up your whole screen. So this is an irrational number. It goes on forever and it does not repeat. 4.37218 ... When you see those ... dots here and you don't know what number is going to come next, that makes it irrational. And negative square root of 21. Let's go ahead and type that in. Negative square root of 21. Enter. And there is another irrational number. Okay, the other number set that real numbers are broken into is called rational numbers. And let's go ahead and take the green and let's glue this down. We're going to glue our pieces down. So he's going to go right there. Okay, the next piece, we're going to open this up. Take your yellow and glue one side of it. And let's glue that right inside, right on the fold. Okay, so now we've got pieces that open like this. The next piece is the purple. And that's going to go on top of the yellow. And the last piece is the blue. I know my colors look funny, I don't know why, but my hover cam makes them look different. Open the purple and put the blue in the middle. Okay, now that that's done, let's fill in our pieces. Close it back up. And remember, I am assuming you did not move as quickly as I did, so you're going to want to pause the video as needed. So these are called my rational numbers. Go ahead and write this on the top of the green. And open it up. And we're going to be writing in the tops of these. So these numbers stop or repeat. If you remember, our irrational numbers went on forever. They did not stop and they did not repeat. To be rational, they have to either stop or repeat. And rational numbers include all of our fractions. So some examples of rational numbers. 1/2 is a fraction, so it's rational. 3.6 is a decimal that stops, so it's rational. 4.813 stops, rational. 2.7 with the bar over it. If you remember, this bar means it repeats. So that's actually 2.77777 on and on forever. Repeats, makes it rational. The square root of 25, if I put that in my calculator and hit enter, I get 5. Okay, 5 is a number that stops, so it's rational. 0 also stops, it's rational. Negative 411 stops, it's rational. Negative square root of 9. Let's check it. Negative square root of 9. Negative 3, that stops, it's rational. Negative 4.21 stops, rational. Negative 3.57 repeating, also rational. Lots of examples for you. Okay, so the irrational numbers, there's nothing that goes with them. So if something's irrational, then it's nothing else other than real. Every number is real. However, if a number is rational, it can also be some other number sets. So our next number set is called our integers. This is an important one. We're going to work with this one quite a bit. So my integers are all rational because they are inside the rational number. So let's open this up. And my integers are all of my positive numbers, the negative numbers, and 0. And it includes all the whole numbers are also integers. And all the natural numbers. And the natural numbers we also call counting numbers. So, this set looks like this, dot, dot, dot. It's going to keep going. Negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 squiggly bracket. So, negative 75, that's what those dots include. All the way that way, all the way this way. 3,407, yep, that's an integer. Okay, our next number set are our whole numbers. And the whole numbers are smaller than the integers. We get rid of the negative numbers. So my whole numbers are all of my positive numbers and 0. Okay, there are no fractions or decimals in the whole numbers, and there are no fractions or decimals in the integers. And this number set looks like this. It starts at 0, so notice there's no dots here. 1, 2, 3, 4, and on and on and on. And this set includes all the natural numbers. All right, our last set are our natural numbers. And another name for this are the counting numbers. And these are easy to remember. Just think about when you first learn to count. If I tell you to count for me, you're going to start with the number 1. So, my natural numbers are all of the positive whole numbers. No fractions, no decimals. Again, think about counting. You start with 1, 1, 2, 3, on and on, forever. Okay, so the next step is to learn how to use this. So I want to know, is the number negative 37, what number sets does that go into? Okay, we know that it's real because all our numbers are real. And then we need to decide, it is always either rational or irrational. Does it go on and on forever? No, it does not. Okay, so let's check rational. It stops or repeats. Negative 37 stops, so it is rational. Now let's check integers. Is negative 37 an integer? Let's see, it includes all the negative numbers, not a fraction, not a decimal, so it is also an integer. Let's check the whole numbers. Positive numbers and 0. So the whole numbers don't have any negative numbers in, so that's it. Those are all the sets that negative 37 falls into. Let's look at the number 4. Start over. Real numbers, well, everything is real, so we know it's real. Is it rational or irrational? It stops, so it's rational. Is the number 4 an integer? It's a positive number, so yes, it's an integer. Is it a whole number? It's a positive number, so yes, it's a whole number. And is it a counting number? It is a natural number. Positive whole numbers? Yes. So it is all of those sets. All right, one more. Let's try the square root of 37. Again, we know it's a real number. Everything is real. And then I need to decide, which side am I going to work on? Is that rational or is it irrational? Let's check our calculator. So the square root of 37, and you'll notice that it rounded it. So if we have 1, 2, 3, 4, 5 decimals afterwards, you can assume that that is an ugly decimal that goes on and on forever, which makes it irrational. And there's nothing else here. Once you decide something's irrational, you're done. So that is our first foldable. You need to get that made. It is going to be glued down on page, let's see, page 5 in your notebooks. So go ahead and glue it down right there. Make sure you put the page number at the top of the page. And when you're done with that, I have a practice activity for you.